Let's discuss the cases of spring combination in SHMs. Basically, spring combinations are used in SHM of spring block pendulums whenever more than one springs are used. I hope you have covered well about combination equivalent of two or more springs. Like if we talk about the series combination of springs is a situation in which if two springs or more are connected one after another having force constants K1 and K2 and say connected to a block resting on ground. In this situation, when the block is displaced, both the springs will be having their individual extensions x1 and x2. So if it is having extension x1, this is having x2. But as the string is common, their tension remains same. So tension in a string can be written as K1x1 is equals to K2x2. And in this situation, the whole system can be replaced by a single equivalent spring for ease and analysis, which is having a force constant K equivalent. And for series combination of two or more springs, the equivalent force constant of the spring can be given as 1 by K equivalent is 1 by K1 plus 1 by K2 plus and so on if more than two springs are there. I hope you can recall in your early classes when you studied about series and parallel combination of resistances. Then if resistances are connected in parallel, their equivalent can be calculated by sum of the reciprocals and reciprocating that. Similarly, in series combination of spring, it is similar to the parallel combination of resistances. By this way, you can keep the result in your mind. Similarly, if we talk about parallel combination of springs, situation is like when two springs are connected parallel to each other and connected to a block, and these are having force constants K1 and K2. And always remember, when the block is displaced, both the springs will get equal extension X. So they'll be having different tensions and individually they are having tensions K1X and K2X, and total tension acting on the block will be K1X plus K2X. So if this system is drawn into an equivalent spring, in this situation, the equivalent force constant can be directly given by sum of the two force constants of the springs, which is the result we use for series combination of resistances. So you just need to keep in mind that whenever springs are connected in such a way that they are having equal extensions and applying force on the block in same directions, they are taken to be in parallel. And these can be replaced by a single equivalent spring which is having force constant equal to sum of the two force constants. And when the springs are connected in series, their equivalent force constant can be given by sum of reciprocals, which is the reciprocal of the equivalent force constant. Let's see some examples based on this analysis also. Let's discuss an illustration to understand the time period of oscillation of a spring combination. Say we are given with a situation in which three springs are connected in this manner, which are finally connected to a block of mass M. And these are having force constants K1, K2 and K3. And say we are given a question to find time period of oscillation of block. So if we are required to find the time period of oscillation of block in this situation, we just first make the system equivalent to a single spring. So first we'll transform it into a spring of force constant K1 connected to another spring, which is the parallel combination of K2 and K3, which can be written as K2 plus K3, and connected to the block, same block of mass M. Now as these two are connected in series, we can replace it by an equivalent spring which is connected to the same block of mass M having force constant K equivalent, and here K equivalent is the series combination of K1 and K2 plus K3. So for series combination we can write 1 by K equivalent as 1 by K1 plus 1 by K2 plus K3, So here on simplifying, we'll get K equivalent is equals to K1 multiplied by K2 plus K3 divided by K1 plus K2 plus K3. So this is the K equivalent. We can directly write the time period of a spring block pendulum. It can be given as 2 pi root of m by K equivalent. That will be the answer to this problem. Let's have another illustration to understand the logic of spring combination. Say we are given with a situation in which a block is placed on a smooth floor which is of mass m and connected to two side walls with the help of two springs having force constant K1 and K2. And we are required to solve the problem for calculation of time period of oscillation of block. The block is slightly displaced and released, it will oscillate under the influence of both the springs. And we are required to find the time period. In this situation, we can see if the block is displaced toward right by x, we can see both the springs will have same extension x and they will exert the force on block in same direction. It will be experiencing a force K1x plus K2x. So this is the situation similar to the case when the springs are connected in parallel. So here in solution we can write, here we can consider K1 and K2 in parallel because there is a situation in which the extension is same and both the springs are applying force in same direction. So we can write its K equivalent to be K1 plus K2, like the block is connected with a single spring. So the time period of spring, it can be directly written as 2 pi root of m by K1 plus K2. This will be the time period of oscillation for the situation given here.